Hello learners, and welcome to today's lesson of similarity and congruency. Let's start off our lesson with a did you know? So, did you know that your hands can help you understand the meaning of congruent and similar? If you put your two hands together, you can see that they are exactly the same shape and the same size. They are congruent. If you put your right hand with your friend's left hand, you can see that they look alike, meaning have the same shape, but are not exactly the same. They are similar. Isn't that fascinating? Let's go on with our lesson and see what we are going to learn for today's lesson. So by the end of this lesson, you should know the minimum conditions for two triangles to be congruent and the minimum conditions for two triangles to be similar. Looking at the concept map for today's lesson. So of course our focus is similarity and congruency. And we are first going to look at similarity, where we are going to be defining similarity and then looking at the conditions for similarity. Then next we are going to be looking at congruency, then where we are going to be defining congruency and looking at those conditions for congruency. And lastly, we are going to be solving some problems. What do we have to know for today's lesson? So you should be able to identify and describe the different types of triangles and calculate unknown angles inside a triangle using the properties of triangles. Let's look at some pre-knowledge practice. So let's identify and name the following triangles. Now, the first triangle here that we've been shown has three angles that are equal, as shown in the diagram. Do we know what type of triangle that is? Yes, this is an equilateral triangle. And how do we know that it's an equilateral triangle? That is because all of the sides are equal, which means all of the angles are equal. And remember, with an equilateral triangle, because we know that all of the angles are first of all equal, and all of the interior angles add up to 180 degrees, that means that the angle can only be 60 degrees. Because 60 degrees is the only angle that when multiplied by 3, the product is 180 degrees. Let's move on to the next triangle, and this is this green triangle here. Now, this green triangle here, we have been shown has one of its angles as a 90 degrees. Now, do you know what type of triangle that is? Well, if you are thinking of a right-angled triangle, then you are absolutely correct. So this is a right-angled triangle, and we know this because one of the angles are a 90 degree, which is a right angle. So this is a right-angled triangle. Let's look at the next angle there, which is that blue triangle there. Let's look at the next triangle. So what do we see about this triangle? This triangle, none of the sides are equal. So none of the sides are equal to each other, which means none of the angles are equal to each other at all. So what type of triangle is that? Yes, you are correct if you are thinking that it is a scalene triangle. So this is a scalene triangle because no sides are equal, no angles are equal. And what about this triangle here? Now we are shown that two of the sides are equal, which means that two of the angles are equal. Remember, the side that is opposite in angle, or the angle that is opposite in equal side, and the angle that is opposite the other equal side, that means those two angles will be equal. So those two angles are equal. And what type of triangle is that? Yes, it is an isosceles triangle. So an isosceles triangle has two sides that are equal and two angles that are equal as well. And those are the type of triangles that we have. Now, let's calculate the value of interior angle B. Now, don't forget, when we are calculating, we need a statement and a reason. Now, this triangle ABC, we have been given the interior angle of A, which is 48 degrees, and the other interior angle of B, which is 55 degrees. And what do we know about our interior angles of a triangle? We know that angle A plus angle B plus angle C will be equals to 180 degrees. And what is the reason for that? That is because they are all interior angles of a triangle. So they are interior angles of a triangle, which means that they are supplementary. They add up to 180 degrees. Now, let's substitute. We have angle A as 48 degrees, plus angle B, which is what we are looking for. Then we have angle C, which is 55 degrees, and they are all equals to 180 degrees. Now, let us go and add our like terms. So that is our 48 degrees plus our 55 degrees. That will leave us with, well, firstly, we have that B, and we are going to have that equals to 103 degrees. And when we use the additive inverse of 103 degrees, we are going to have 180 degrees minus 103 degrees, and that is going to give us an answer of 77 degrees. And that is the value of that angle B. That is 77 degrees. Let's move on to another question. So we have there, calculate the length of QR if PR is equals to 13 centimeters and PQ is equals to 5 centimeters. Now this is a right-angled triangle, which means firstly there is a 90 degrees there, and that's how we see that it's a right angle triangle. And also when we are calculating sides, this means that we can use Pythagoras to solve for our unknown side. So we know that Pythagoras says that PR squared is equals to PQ squared plus QR squared. And we've been given PR as 13 centimeters squared. And we have PQ as 5 centimeters, and we're going to square that, and that is QR squared. And remember, we are writing the statement because this is the Pythagoras theorem. Then 13 centimeters squared is 169 centimeters squared. That is equals to 25 centimeters squared. When we are going to square that 5 centimeters, that leaves us with QR squared. And for us to solve for QR squared, we need to use the additive inverse of 25 centimeters squared. So we are going to say 169 centimeters squared minus 25 centimeters squared, and that is equals to QR squared. Now, what would QR be? QR squared be? That's 169 centimeters squared minus 25 centimeters squared will leave us with 144 centimeters squared. And what number do we square? And the answer is 144. If you are thinking of 12 centimeters, then you are absolutely correct, because that is our answer for QR. So QR is 12 centimeters. Let's move on to the keywords that we are going to use during this lesson. So firstly, we are going to look at similar triangles. Those are when all interior angles are equal and when the corresponding sides are proportional. Same shape, but not necessarily the same size or the same area. And as we can see there, triangle ABC and triangle DEF. Triangle DEF looks bigger than triangle ABC, but because they have the same shape, we can see that they are similar. Then we have proportional, which means that the ratios, these are ratios with equal simplest forms. So when we are looking at AB is equals to AC, that would be equal, when we are looking at AB divided by AC, that would be equals to DE divided by DF. Now, this doesn't mean that AB is equals to DF, but what it does mean is that after we divide AB and AC, that simplest form will be equals to DE divided by DF, and that would mean that they are in proportion. Then we have the corresponding sides, and these are opposite the equal angles. So as we can see with our diagram here, we can see that it is shown that angle A is equal to angle D. Now, when we are talking about the corresponding sides, since as well we said opposite the equal angles, we can see that the side that is opposite angle A is BC. And since as well angle A is opposite BC, it means the corresponding side would be the side that is opposite the corresponding angle. So we did say that angle A is equals to angle D. So the corresponding side or the opposite side to angle D would be EF. Now in this case, it would mean that BC is corresponding with EF. And why? Because they are both opposite equal angles. Now the same would be true for the sides that are opposite angle B and angle E. Since as well it is shown that angle B and angle E are equal, it would mean that AC, which is opposite angle B, and DF, which is opposite angle E, are corresponding. So AC and DF are corresponding sides. Then we also have congruent triangles, and those are equal size, same shape. They fit exactly on each other, like your hands that we spoke about in the beginning of the lesson. So looking at these two triangles there, we have triangle ABC, and that would be congruent to triangle NMP. As you can see here, you will see that those two triangles, they fit exactly on each other. So those are congruent triangles. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to be moving into the first part of our concept map, and that is similarity. So let's start by defining similarity. When two objects or shapes are similar, they have the same shape, but not necessarily the same size. So for example here, we have a few shapes here that we can see are the same in shape, but not necessarily in size. Let's look at this first arrow here. So as we can see, it is an arrow, yes, and it's facing a different direction from the other arrow, but we can see that they have the same shape. They are both arrows. But what do we notice about them is that they are not the same size. So this one is smaller than this top one there. But because they have the same shape, then it means that they are similar. Let's look at the next object here. So we have a smaller object, and we have the same thing but in a bigger version. So we can see that they are the same shape. If we were to rotate them, they would be exactly the same shape, but they are not the same size. As we can see that this top one is smaller than this bottom one here, but they are similar. Why? Because they have the same shape, but not necessarily the same size. And of course, we have two stars here that look the same, but have different sizes. So that is similarity, the same shape, but not necessarily the same size. So when we are looking at similarity, we also look at the corresponding angles and the corresponding sides. Let's see what we mean by that. So corresponding refers to sides or angles that occupy the same position in a shape. So they occupy the same position in a shape. Let's look at a few examples. So we have the first example there of two shapes that are corresponding in sides or in angles. So when we're looking at these two shapes, we have here a trapezium. And how do we know that it's a trapezium? Because we can see that one pair of the sides are equal, and it's an isosceles trapezium because we can see that two of the sides are equal. So we have ABCD, which is bigger than KLMN. But if we look more closely, we can see that they are equal angles. So if we look at angle A is 108 degrees. Now, if we look at angle K, it is in the exact same position in two different shapes. So they are corresponding because they occupy that same position that defines corresponding. Now, if we look at angle B, it is also 108 degrees, and angle L is 108 degrees. And of course, those two angles are equal because this is an isosceles trapezium, but they are corresponding. Why? Because they are in the same position in that shape. Now, the same can be said with angle D and angle N, as they are both 72 degrees and they occupy that same position. And of course, the same can be said about angle C and angle M as well. So this means that those angles are corresponding. And when we look at the corresponding sides, we can see, remember, a corresponding side needs to be opposite a corresponding angles. And since as well we said angle M and angle C are corresponding, now the sides that are opposite that is AD, and the side that is opposite the angle M there is KN. So this would mean that side AD is corresponding with side KN. So when shapes are also similar, what we should know about their corresponding sides or their sides is that they will be proportional. So let's look at this pentagon that we have been given here. And if we were told that these two shapes are similar, then we would know that the ratio of SW divided by WV would be equals to, now because we were told that they are similar, that means that SW corresponds with KO. So this would mean that it would be equals to KO divided by, now we would have to go now and take a side that corresponds with our WV. And which side is that? Yes, that would be our ON. So that would be divided by ON. And since as well we have values in this first pentagon here, then that means that we can go say that SW divided by WV will be equals to that 3 divided by that 3,5 centimeters. And we would be able to calculate that because the shapes are similar. Let's move on to our next slide, which is similar triangles. Now, when we are working with two triangles that are similar, one of the following conditions must be true. So either the ratios of corresponding sides are in proportion, or all the corresponding angles are equal. Let's look at an example. So we have here two triangles. So triangle ABC and triangle PRQ. Now, if these two triangles are similar, one of these conditions must be true. One or both of the conditions must be true. So let's look at the ratios of those corresponding sides. Now, let's take, for example, the hypotenuse. So we know that the hypotenuse is the one that is opposite the 90 degrees, because as we can see, both of these triangles are right angle triangles. And we know this because of the 90 degrees that has been given to us there, or that has been shown to us there. So in this triangle ABC, which one is the hypotenuse? Yes, it is the longest side, and the one that is opposite the 90 degrees, and that is our AC. And the corresponding side to this hypotenuse would be the hypotenuse in the smaller triangle, which is triangle PRQ. And the longest side in this smaller triangle is PQ. So that means that AC is corresponding to PQ. What about the other sides? Now, when we are looking at triangle ABC, we can see that the smallest side here is AB, and we see that it is the smallest side because of the measurements that have been given to us there. So between 10 centimeters, 8 centimeters, and 6 centimeters, the smallest side would be AB because it has 6 centimeters. What about triangle PRQ? Now, triangle PRQ has measurements of 5 centimeters, which is our hypotenuse, and we've already identified that as the longest side. Then we have 4 centimeters, and then we have 3 centimeters. So out of those 3 measurements, the smallest measurement would be 3 centimeters, which is side PR. Now, how would we show that the ratios of the corresponding side are in proportion? Let's take these two sides that we just looked at now. So, for example, let's say AC divided by AB. Now, as you can see, I have taken the hypotenuse and I have divided it by that smallest side there. So, AC in this in the larger triangle is equals to 10 centimeters. And AB is equals to 6 centimeters. Now, that is the ratio of the bigger triangle, and if we simplify that ratio, that is actually going to give us the 5 centimeters divided by 3 centimeters, and that is the simplified ratio of the larger triangle. Let's look at the corresponding sides, or the ratio of the corresponding sides. Now, we had said that AC corresponds with PQ, so we are going to say the PQ divided by PR. So this is going to be now, as we have seen, the length of PQ is 5 centimeters, and we are going to divide that by that smallest side, which is 3 centimeters. Now we can see that 5 centimeters divided by 3 centimeters is already the simplified ratio of that ratio. So when we look at the two ratios, we can see that they are equal. In fact, they are in proportion. So we can see that this means that these two triangles are similar. Why? Because the ratios of the corresponding sides are in proportion. What about the angles? Because another condition that would make these two triangles similar is that all the corresponding angles are equal. Now, we've already identified one angle that is equal, or one pair of corresponding angles that is equal, and that is angle B, which is 90 degrees, and angle R, which is also 90 degrees. So we can see that angle B is equals to angle R. But when we look at angle C, we can see that angle C is equals to 37 degrees. So angle C is equals to 37 degrees, and when we look at the smaller triangle, angle Q is also equals to 37 degrees. Maybe we can write that down, just like angle B and angle R are both equal to 90 degrees. And lastly, when I look at angle A, I can see that it has a measurement of 53 degrees, which is also the same as angle P in our smaller triangle. They are both equals to 53 degrees. Now notice how we said that for these two triangles to be similar, all of the corresponding angles must be equal. And as we have just shown there, all of the corresponding angles in these two triangles are equal. Now, what conclusion does that bring us? We can see that because both of these conditions are met, then we can see that triangle ABC is similar to triangle PRQ. And remember, we don't need both of the conditions to be met, but we just need one of the conditions to be met. And then we can conclude that these two triangles are similar. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson. Welcome back from the ad break, and let's continue with our lesson. So we are now going to be looking at congruency, which is the next point in our concept map. So let's look at congruency. When two objects or shapes are congruent, they have the same shape and the same size. So for example, we have an arrow and another arrow. Now, as we can see, these two arrows, even though they have a different color or have a different orientation, but we can see that they are the same shape, and we can see that they are exactly the same size. When we are looking at the shape here, we can see that it just has been rotated, but we can see that they have the same shape and the same size. And lastly, looking at these two stars, they might be a different color, but they really are the same shape and they have the same size. So that is what congruency means here. But what about congruency of triangles? Now, two triangles are congruent if the conditions below are met, and only one of these conditions needs to be met. So let's look at the first condition there, and that is side, 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 of which we represent using an S, an S, and an S, because that S is for side. Now, what does that mean? It means that all corresponding three sides are corresponding, or all the three sides are corresponding sides. The second condition would be when we have a side, an angle, and another side. Now, if we have two sides and the angle that is between those two sides, then we can say that the two triangles are congruent. So we say that it's the angle that is included by the sides. Why? Because it is in between those two sides. And that is represented by an S, an A, and an S. So it is two sides and the angle included. Then we have the third condition, which is an angle, and a side. So these are two angles and a corresponding sides. So in a triangle, it would be two of the corresponding angles and, of course, the corresponding side. And lastly, we have RHS, which is a right angle, the hypotenuse, and another corresponding side. So a 90-degree angle, the hypotenuse, and another side. So let's look at these conditions individually. So we have here two triangles, triangle PQR and triangle MNL. And we have the measurements that are given here. So we can see that we have 11 centimeters for PR and we have 11 centimeters for MN. So this would mean that PR is equals to MN. Then we have 14 centimeters for QR, but we also have 14 centimeters for ML. So that means that QR is equals to LM or ML. And then lastly, we have 20 centimeters for QP and we have 20 centimeters for LN. So that means that QP, that means that our QP there is equal to our LN. So because we have three sides that are equal, or the corresponding sides are equal, then we can conclude that that means that triangle PQR is congruent, and that is the symbol for congruency. So it would be congruent to triangle. Now remember, you should be careful that the corresponding sides must be placed in the correct order. So that would mean, because we started with PQ, and PQ is the one with 20 centimeters, so we are going to start there with NL. And lastly is R, so PQR, so that would be NL and M. So it means that those two triangles are congruent. Let's move on to another condition. So that is the side angle side. Now looking at these two triangles here, we have been given triangle PQR and triangle GHL. And we can see here that we are given that these two sides are equal. That is side PR and QR. But since as well PR has been given as 16 centimeters, this means that QR is also 16 centimeters. And we can see that angle G here is 88 degrees and angle R here is 88 degrees. So in both triangles we have two sides that are equal to 16 centimeters and we have two angles that are equal, we have one angle in each triangle that is equals to 88 degrees. So here we can see that PR is equals to GH, and we can see that angle R is equals to angle G. And lastly, we see that QR is equal to GL. So what does that mean, or what conclusion can we make? It means that triangle PQR will be congruent to triangle HLG. And those are the two triangles that are congruent. And what is our reason for this? Our reason for this would be that we have a side, an angle, and a side. So always remember to write your reason why you are concluding that these two triangles are similar. So even in the previous one that we started with, we did say that triangle PQR is congruent to triangle NLM, and our reason there was because we found three corresponding sides that are equal. So our reason there would be SSS. Let's look at another condition for congruency, and that is when we have two angles and a corresponding side. So let's look at the two triangles here, and we can see that in triangle RST we have been given angle R, which is 56 degrees, angle S, which is 83 degrees, and we've also been given here 4 centimeters for side RS and 7 centimeters for side RT. Now, because all we need is two angles and a corresponding side, now we go over and look at triangle ABC. And in this triangle, we've also been given angle A, which is 56, and angle B, which is 83 degrees. And again, we've been given AC, which is 7 centimeters, and we've been given AB, which is 4 centimeters. Now, as we are looking at these given sides, we can see that they are indeed corresponding. RT is opposite angle 83. So it is corresponding with AC, which is also opposite angle 83. So they are definitely corresponding there. And as we can see there, angle R is equals to angle A, and angle B is equals to angle S, and we have those corresponding sides that we spoke about, which is RT, which is equals to AC. And because we have these three conditions, we can conclude that we have triangle RST, and that is congruent to triangle ABC. And our reason for that, now we have to be careful, is because we found an angle, and the corresponding side. So in that order, it would be an angle, and the corresponding side. And remember, this condition of congruency is two angles and a corresponding side. So we could have also used angle S, because it is corresponding with angle B, and we could have used angle R, which is corresponding with angle A, and of course we could have used side S, because we have been given that as 4 centimeters, which is the same as, or which is corresponding with side AB, which is also 4 centimeters. It is still 2 sides and a corresponding, it is still 2 angles and a corresponding side. Let's move on to the last condition of congruency, and that is RHS, which is a right angle, a hypotenuse, and another side. Now, when we look at these two triangles that we've been given here, that is triangle ABC and triangle PQR. So, are they congruent? Yes, they are, because we can see that firstly, there is a right angle. So there's the right angle. It has been shown to us in both of the triangles. So that means that angle B is equals to angle P. Then we have the hypotenuse, which is AC in this triangle, and it's been given as 17 meters. So AC is equal to, when we look at the other triangle, we have been given as 17 meters, which is QR. So that is QR. And then we can see that we have a side that is corresponding in length as well. We have BC, and that is equal to PR. So that means that these two triangles are congruent. So there, that is triangle ABC. And of course, that symbol for congruency. And we will say that it is congruent to triangle QPR. And what is our reason for saying that? That is right angle, hypotenuse, and a corresponding side. Let's now go to the last part of our concept map, and that is solving problems. And we are just going to see if we can determine whether these two triangles are congruent or not. So determine if a triangle DEF is congruent to triangle MHL. Now, these are both isosceles triangles, and we can see that DE is equal to MH, which is 9 centimeters. So they are equal, and because we were given that DE is equal to DF, that means DF is also 9 centimeters. Again, we're given that MH is equals to ML, so that means that ML is also 9 centimeters. So we already have two sides that are equal here. Now let's look at the angle. Are the angles equal or not? Now we are thinking of the conditions of congruency that have two angles. So remember, we have the side, that have two sides. So we have the side, or we have the side angle side. So we are either going to use one of these two conditions to prove our congruency. Now, because we don't have the third side there and we can't calculate it, if it were a right angle triangle, we would be able to calculate it. So that means we are not going to use this condition of congruency. So we are looking at the two sides with the included angle. Now, in triangle DEF, the included angle is 52 degrees. In this triangle MHL, we do not know the value of the included angle, but we can calculate it. Now, we have been given 64 degrees for angle L, but angle L is equals to angle H, which means it is also equals to 64 degrees. Do you remember the reason for that? It's because the angles are opposite equal sides. So that means that they are also equal. So we have 64 in that angle H. And if we now use the interior angles of a triangle to calculate the third angle there, then we can simply say that the 64 degrees for angle H plus the 64 degrees for angle L plus angle M, that is going to give us 180 degrees. And our reason for this is that they are interior angles of a triangle. Right? And then we have the 64 plus 64, which gives us 128 plus angle M. And if we use the additive inverse of 128 degrees, we are going to have 180 minus 128 degrees, and that is 52 degrees. So we can see there that angle M is 52 degrees. Now, angle M is equal to the corresponding angle D because it is the included angle between the two equal sides. So what does this mean for our two triangles? It means that yes, indeed, triangle DEF is congruent to triangle MHL. And what is our reason for proving this congruency? It's because we had two sides and the included angle. So our reason here is going to be our SAS. That is the end of our wonderful lesson. Thank you for joining us, and we hope to see you next time. Goodbye.